Hi everyone, this is kind of a continuation of what we learned with air masses. So here's that last slide from the air masses where we had continental Arctic, we had continental polar, we had maritime polar, we had continental tropical, maritime tropical air masses. The idea of this next lesson is what happens when those things combine on the surface of Earth. So what happens when a maritime tropical air mass meets a continental polar air mass? What's it going to be like? So I like to start with the profile view of it. And I like to start with the left side in blue for a cold front and the right side in red for a warm front. And I drew the ground in green, and I'll draw two people to show like that's ground level and this is a cross section. So when you have a cold front and warm front, it means that you must have both types of air. The fronts technically start at the bottom or at ground level. So this is the beginning of the warm front. This is the beginning of the cold front. And so if I have a warm front, that means I have warm air. So this middle section is all warm air. We could say that it's maritime tropical. And in front of that front would have to be cold air. That makes a difference of like kind of a boundary in between warm air and cold air. So this cold air could be something like continental polar. And so what's going to happen in this area is a reaction of the mixing of two different types of air. So warm air, because it has a low density, is going to slowly rise above the cold air. So here I'll have my warm air slowly rising up due to REC, if we remember that. Warm air rises, expands, cools, condenses to make clouds. And we will have rain in front of the warm front. That's kind of like a mellow rain. And it'll rain for like pretty long, very long time raining. But it will be a mellow rain and the clouds will spread out along the entirety of the sky almost. And after that front passes that person, then you'll have a nice warm day. So maybe it'll rain for like a whole day and the next day will be kind of a nice warm day. Now you have the cold front. You'll notice it's a kind of a different shape. It's almost kind of like what I describe as like a bulldozer. And so sometimes cold fronts move faster than warm air. And they kind of push warm air up, straight up. Warm air doesn't have the chance to rise slowly. It has to go straight up that wall of a cold front. And so if it's cold air, we'll say again that it's continental polar. So in this case, instead of that nice slow rise up a ramp, warm air is forced upwards, what we would say, how we would describe as violently. And the clouds will build on or behind the cold front. And instead of being horizontally spread out throughout the whole sky, there's a chance that they just stack vertically. And when these clouds stack vertically, that's when you have something that could cause a lightning storm on or behind a cold front with really heavy rain instead. So those are our cross sections or profiles of a warm front and a cold front. Now, there's also a stationary front and an occluded front. I would just take a look at the symbols, make sure that you know on page 13 you can find all of these things. But it takes a while to explain cold and warm. I don't want to do a half-hour video. So here I have windy.com. I highly recommend it. It's a really good website if you want to study the wind and see how low pressure and high pressure systems work. This is for today at 11 o'clock. You might not be watching it on Monday at 11 o'clock, but this is actually what happened. So you'll see that we have air coming from this direction if I follow like the particles. So up here would be kind of like Canada, right? I mean, it is Canada. And so we would probably have a continental polar air mass moving in. So all this air is continental polar, right? That's why I have a cold front symbol in front of it. Now you'll see that I have from the south, I have this set of air moving in as well. And because it's over the ocean and because it's from the south, I would say that this is most likely a maritime tropical air mass. And so I don't have the wind, I don't have all of it. I just have kind of like the general direction and movement of the fronts. But here is a real life general synopsis of continental polar air masses meeting maritime tropical air masses and what I would assume is the area where the fronts are. All right, and you'll notice that everything is moving around a low pressure system in a counterclockwise and in type movement when we learned how wind moves around certain pressures. All right, so again, windy.com is a great website if you wanted to check out daily wind movement, low pressure systems, isobars, and it's really good in the winter. It predicts snow very well. I like it a lot. All right, have a good rest of your day. Thanks for watching.